Hi guys, it's me, Miss Montague. Welcome to math. Just a reminder, we have our number talk later, so don't forget to join us for our number talk at 1 o'clock from 1 to 1:30. Okay, so if you're watching this in the morning, make sure that you don't miss our number talk. Okay, we're gonna go ahead and we're gonna look at a couple mathematicians' arguments today, and then we're gonna talk a little bit about that irregular figure, the one that looks a little different than the other ones. Okay, so here we go. Let's do a quick share. Get ready to think. Chink, chink. Okay, so here is one of our students' work, student 1, and the argument that they're saying is that figure C does not belong. What do you notice that they did as a mathematician? How did they support their thinking? Okay, so one thing that I noticed is that they labeled the dimensions of the irregular figure. So he says that she says that it's 2 by 2 on the top and then 2 by 4 by 2. So a width, a length, and a height. So 2 for the width, a length of 4, and then a height of 2. Okay, so this one does look different than a typical rectangular prism. And then this mathematician also supported it with an equation down here. So here's the volume for D, here's the volume for B, here's the volume for C, and here's the volume for A. There's a really interesting pattern happening in this student's work. What do you notice about the volume for each rectangular prism? This volume for D, it looks like it's 24. So the figure is made up of 24 cubes, okay? So it takes up space. This three-dimensional figure takes up space of 24 cubes. B, also 24 cubes. C, 64 cubes. A, 24 cubes. Very interesting. I really like to see those patterns right next to each other, okay? Let's see if another mathematician agrees with this argument. Okay, this mathematician totally agrees with the first mathematician. This person is saying that, hey, this third prism, this irregular figure, doesn't belong because it looks like it has 2 heights. So how would I actually calculate or find out the volume of a figure that has 2 heights? That's a really good question. So it looks like this mathematician came up with 48 as the volume for the irregular figure. Very interesting. We have a volume of 48 and then we have a volume of 64. Both are pretty big outliers to the actual volume of 24. Okay, but which one's accurate? Okay, this mathematician did something really interesting also. They believe that this third figure, this irregular figure, is the one that doesn't belong. Okay, so far a lot of you are saying, hey, this ABC or this third figure does not belong. It looks different. It's the only one that has a rectangular or a figure on the top and a figure on the bottom. So this person actually made it into 3 square prisms. That's really interesting. I wonder if that can help us figure out the volume. Maybe that could be a strategy. Okay, so we have some really great thinking going. We have a lot of people that agree that this irregular figure is the one that does not belong. I'm going to show you what we can do to calculate the volume of a figure like this. And it might change our thinking a little bit as a mathematician. Okay, so here I have my irregular figure. And the really interesting thing about this rectangular prism or figure is that I have a rectangular prism on the bottom and then I have a square prism on the top. And when I put them together, that makes that irregular figure. But as a mathematician, I don't have to think about it together. Like that third mathematician, they kind of took the figure apart. Now, does this change the volume? Do I have any less or any more cubes than I did before? No, I still have the same volume. But as a mathematician, this is a great strategy to think about the figure in a different way. Today, I'm going to separate it just like this. I'm going to have the top figure, I'm going to think about that one, and then I'm going to think about this figure on the bottom. So I'm just going to think about them separately when I'm trying to calculate the volume. Okay, so that second mathematician that said, hey, it looks like they have two heights, this would be a great strategy just to take the figures apart. Okay, so the bottom figure, I'm going to pretend these cubes are centimeter cubes. They're not centimeter cubes, but just to think about it as with a unit of measure, we're going to pretend they're centimeters. They're actually 2 centimeter cubes, but today we're going to pretend they're just 1 centimeter. So I'm going to say this is made up of 4 cubes or 4 centimeters. Okay, the width, so that's the length, the width is 2 centimeter cubes. And then the height, 1 cube, 2 cubes, 2 centimeters, or 2 centimeter cubes. Okay, this top figure, I have a length of 2, a width of 2, and a height of 2. Okay, so that goes back to the fact that this is a square prism. It's a little different than a rectangular shape. Okay, so one of the ways that I can think about this prism is I can count this bottom one, this rectangular prism, I can count by multiples of 4. 4, 8, 12, 16. Okay, so there's 16 cubes there. I can count each cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 cubes. Okay? I just did 2 strategies right there. I used multiples, and then I also just counted each cube. Okay? Both are strategies to find volume. Okay? Another strategy that I can use is by taking the height, the length, and the width, and multiplying them together. 4 times 2, or 2 times 4, is going to equal 8. 8 times 2 equals 16. Okay, so this bottom figure, this rectangular figure, has a volume of 16 centimeters cubed. Okay, we're just pretending that these are centimeter cubes. Okay, now the top figure, I can do the same thing. I can think about it as 4 cubes, then 8 cubes. Okay, so I can just count the cubes. Or I can just count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this square prism is made up of 8 cubes. I can also, to find the volume, is 2 times 2 times 2. So 2 times 2 equals 4. 4 times 2 equals 8. Okay, I'm thinking, remember, when I'm trying to calculate volume, I'm thinking about how much this three-dimensional figure, how much space it takes up. Okay, so this rectangular prism and this square prism, when they're together, how much space do they take up together? So I have the 8 centimeters cubed, and I have 16 centimeters cubed. This is going to give me the total volume of the irregular figure. So if I take the volume of this figure and add it to the volume of this figure, that's going to give me the total volume. Very interesting. I wonder what 16 plus 8 is. What's the total volume of this irregular figure? Some of you guys are also thinking about volume as base times height, and that's another way to calculate or think about volume. Okay, so if I know that my base is made up of 4, okay, and my height is 2 cubes, so my area or my base is 4. 4 times 2 equals 8. Okay, so that's another strategy you can use, or equation that you can use to calculate the volume. Okay, so as a mathematician, is this changing your thinking at all? Do you still believe that C doesn't belong? Why? Why do you think that? Why or why not?